All right, let's get ready because today we are going deep on Android app development.
Ooh, exciting.
Yeah, we're talking about everything that makes those apps you use every single day actually work.
Like what's going on under the hood?
Yeah, like how it all comes together, the architecture, the tools.
The magic.
Exactly. And to help us figure all this out, we've got this Romanian academic paper that we're going to break down just for you.
Oh, cool.
It's all about making this complex stuff, digestible and fun for everyone listening.
So let's start with
So Android architecture, like how a house needs a solid framework before you can start decorating.
Yeah, for sure.
That's kind of how it is with apps.
Exactly. Android is built in layers, with each one having its own specific job. And at the very bottom, you have the Linux kernel.
Okay, so like the bedrock.
Yeah, exactly. It manages all the core stuff.
Like what kind of stuff are we talking about?
Like memory and processing power, and even things like the battery and all the sensors on your phone.
Oh, so that's why my battery dies so fast when I have a ton of apps open.
Yeah, possibly. It all comes down to how well the kernel manages those resources.
Interesting. So that basic layer really impacts how the whole phone runs.
Totally. Like, if the kernel's doing its job well, then things like multitasking and power usage can run super smooth.
Makes sense. So what's the next layer up?
Above the kernel, you've got the libraries.
Libraries.
Yeah, these are basically like pre-written chunks of code that take care of all sorts of things, graphics databases, multimedia playback.
Oh, so like instead of having to write all that code from scratch every time, they can just kind of pull from these libraries?
Exactly. It's way more efficient. You can think of it like having a toolbox full of specialized tools.
Oh, that's a good analogy.
Right? Instead of reinventing the wheel every time, you can just grab the tool you need.
Smart. So that must save developers a lot of time.
Definitely. And then above the libraries, we have the Android runtime.
Okay, the runtime.
This is where the code for your app actually gets executed, and its lifecycle is managed.
Hold on, life cycle. So are you saying apps have like lives too? Or?
In a way, yeah. You see, an app actually goes through different stages, from being launched to running in the background to eventually being closed.
Huh.
And each stage needs specific actions to happen.
Oh, okay.
The runtime makes sure all that happens in the right order and that resources are being used efficiently.
Like a conductor for an orchestra?
That's a good one. The runtime is making sure the whole app is playing the right notes at the right time.
Cool. So we've got these three layers, the kernel, the libraries, and the runtime.
Right. Those are the core layers of the architecture.
But how do developers actually build on top of all that? Our source mentions all these different tools.
Yeah, so there are these things called integrated development environments, or IDEs.
IDs.
Yeah, and developers use them to write the code for the app, test it, and package it all together.
So like the IDE is the developer's workspace?
Pretty much. Some IDEs are more popular than others, though, and the choice really depends on personal preference, project requirements, and even cost.
Yeah, the source actually has this whole table comparing these popular IDEs like Eclipse, IntelliJ IDEA, and Visual Studio, and the price range is crazy. It goes from free to almost $3,000?
Yeah, but pretty wide range.
Wild. But our source mainly talks about Android Studio. Why is that one the go-to?
Well, it's developed by Google, so it's super tightly integrated with the whole Android ecosystem. It gets all the latest updates and features first.
So it's like the official tool.
Exactly. Using the official tool definitely has its advantages.
Okay, so what makes Android Studio so special? What kind of features are we talking about here?
Well, one of the big ones is Gradle.
Gradle?
It's this super powerful build system. Think of it like a project manager for your code.
Huh.
It handles all these tedious tasks that would take forever to do manually.
Like what?
Things like compiling the code, packaging it up, and even managing dependencies.
Dependencies, what are those?
Oh, those are basically external libraries that developers might use in their apps.
So Gradle just takes care of all of that behind the scenes.
Yep, it makes sure everything is running smoothly.
Wow, that's awesome. What else is there?
Another really cool feature is the emulator.
Emulator?
Yeah, it's a game changer for testing.
How so?
Well, imagine being able to test your app on a whole bunch of different virtual devices, like different screen sizes, resolutions, even different Android versions, all without actually having to own a bunch of phones.
Oh, that's smart.
Right? It saves developers so much money and hassle.
For sure. But wouldn't managing all those virtual devices be a nightmare?
It could be. But luckily, Android Studio has this built-in AVD manager that makes it pretty easy.
AVD manager?
Yeah, AVD stands for Android Virtual Device.
Okay.
So developers can create, customize, and organize all their virtual devices right within Android Studio.
So they can make sure their app looks and runs great on basically any device.
Exactly.
That's super cool. The source also mentions this instant run feature. What is that all about?
Oh yeah, that one is a huge time saver for developers. Basically, they can make a change to their code and then see that change reflected in the app almost instantly.
Wow, so they don't have to go through that whole process of recompiling and reinstalling the app every time?
Nope. It makes the development process so much more efficient.
That's incredible.
And then on top of all that, Android Studio also has these really extensive testing tools built in.
Okay, so what do those do?
Well, they allow developers to write automated tests.
Automated tests.
Yeah, so these tests basically check for bugs and make sure the app is working correctly.
Oh, so it's like a safety net to catch all those errors before they get to the users?
Precisely, because nobody wants to deal with a buggy app.
Yeah, those are the worst.
So these testing tools are super important for making sure the app is polished and ready for prime time.
Makes sense. Our source mostly focuses on emulators for testing, but I imagine testing on real devices is still important, right?
Oh yeah, definitely. Because you never know what kind of weird stuff might happen out in the real world that an emulator just can't replicate.
Right, like different network conditions or weird hardware configurations.
Exactly. So it's important to do both emulator testing and real device testing to make sure the app is truly ready to go.
Good point. So we've covered the basics of the Android architecture and some of the key tools that developers use.
Yep, especially Android Studio.
But what about the app itself? What does that actually look like under the hood?
Oh, that's where things get really interesting.
Okay, I'm intrigued. Let's get into it.
It's like crashing open an app and seeing all of its inner workings laid out like a blueprint.
Okay, I'm ready to see this blueprint.
All right, let's dive in. So we left off talking about how an app looks under the hood, like a blueprint.
Right, breaking down the anatomy of an app.
Exactly. So when you're looking at an app, what you see and interact with, it's all built from these things called activities.
Activities, okay.
You can kind of think of them like rooms in a house. Each one has a specific purpose.
So like if I'm on a social media app and I switch between my news feed, my profile, and the messaging section, each of those is its own separate activity.
Exactly. Each activity has its own layout, functionality, and life cycle.
Wait, life cycle? Again, so these activities are actually born, live, and then die, or what?
That's one way to put it. But yeah, each activity goes through these different stages.
Right.
Creation, start, pause, resume, stop, and then finally destruction.
Wow, that's kind of deep.
It is. And developers actually use these different life cycle stages to make the app run more efficiently.
Okay, so like how does that work?
Well, for example, when an activity is paused, like let's say you switch to a different app, that paused activity shouldn't be hogging up all your phone's resources.
Right, that makes sense.
So developers can use the life cycle to tell the app to basically chill out when it's not being used.
So it's like saving battery life and stuff.
Exactly. It's all about optimization.
That's pretty cool. So activities are these building blocks of the UI,
right?
But they don't just exist on their own, right? They need like content and instructions.
You got it. And that's where those resource folders come in.
Oh yeah, we talked about those earlier.
Remember, they hold all the non-code elements, like the images, layouts, strings, and styles.
So they basically give the app its look and feel.
Exactly. You can see the activities are like architects, and the resources are their building material.
I like that analogy.
So for instance, let's say you've got a login screen for an app.
Okay.
The layout file from the resources would define where all the different elements go.
Like where the text fields are, the buttons, the logo, all that stuff.
And then the activity brings that layout to life.
So it handles the user input.
Yeah, and then it checks if the credentials are correct, and it might even display error messages if something's wrong.
Oh, okay. So the Java code in the project is what defines the logic and behavior of the activities.
Right on. It's starting to come together now, isn't it?
It is. But there's got to be more to an app than just screens and buttons, right? Like, what about things that happen in the background?
Like notifications?
Yeah, or like when music keeps playing even after I've switched to a different app.
Very exactly right. And that's where services come in.
Services.
These are like the invisible workers of the app world. They can perform tasks even when the app isn't front and center.
So even when you can't see them, they're still working away.
Like when you're downloading a large file or streaming music.
So they're kind of like the stage crew, making sure the show goes on behind the scenes.
I like that analogy, master, right there.
Haha, thanks. So we've got activities and services. What else is going on behind the scenes?
Well, then we have these things called broadcast receivers.
Broadcast receivers.
And these guys are like the app's senses. They're tuned into all sorts of events happening on the phone.
Like what kind of events?
Oh, things like incoming calls, network changes, or even when you plug in headphones.
Wow, so the app is actually aware of its surroundings.
Yep, and it can react accordingly.
That's so cool. So is there anything else working behind the scenes?
Yeah, we also have content providers.
Content providers? What are those?
These allow apps to share data with each other.
Wait, so apps can actually talk to each other?
In a way, yeah. It's like they have this secure channel where they can exchange information like contacts, calendar events, or even custom databases.
I never really thought about apps sharing data with each other before. Is that like a security risk or anything?
It can be if it's not done carefully, but luckily there are a lot of security measures in place to control how that data is accessed and shared.
Okay, that's good to know.
And users also have control over what permissions they give to apps.
Right, right. So it's all about being responsible and making informed choices.
Exactly. So back to the app's inner workings, we've talked about all these different components working together. But how do they actually communicate with each other?
Yeah, like, is there some kind of messaging system going on?
There is, and it's called intents.
Intents? Interesting.
Think of them like messengers carrying instructions between all the different parts of the app.
So like activities and services and broadcast receivers all talking to each other.
Exactly. Intents can trigger actions, share data, and even ask other apps to do things.
Wow, that's pretty complex.
It is, but it's what makes the whole system work so smoothly.
This is blowing my mind. It's like a perfectly choreographed dance happening behind the scenes.
It kind of is. And we haven't even gotten to things like fragments and widgets yet.
Fragments and widgets.
Yeah, fragments are these modular UI pieces, and widgets are those interactive things you can put on your home screen.
Oh, right.
But we'll have to save those for another deep dive.
Yeah, my brain is already overloaded.
Haha, I hear you. But it's pretty amazing how much complexity is packed into those apps we use every day, huh?
It really is, but I imagine it's not all sunshine and rainbows for developers, right?
Definitely not. There are definitely some challenges that come with building Android apps.
Like what?
Well, one of the biggest ones is the sheer diversity of devices out there.
Right, all those different screen sizes, resolutions, and Android versions.
Exactly. It can be a real headache for developers to make sure their app works perfectly on all those different devices.
So it's not just about making the app work, it's about making it work well on every single device.
Precisely. And that could be a lot tougher than it sounds.
Okay, so fragmentation is a big challenge. What other hurdles do developers face? So we were talking about all the challenges that come with Android development.
Yeah, like how do you make an app that works well on literally millions of different devices?
Right, with all those different screen sizes and specs and everything.
It's a lot to think about. And, it's not just about making the app functional either.
It's got to look good, too.
Exactly. You want to make sure the user experience is consistent and enjoyable no matter what device they're using.
That makes sense. So, like, how do developers even approach that challenge?
Well, it starts with making some strategic decisions.
Okay, like what?
Like which Android versions they want to support, which screen sizes to optimize for, and how to handle things like different processing power and memory limitations.
So it's like they're trying to find the sweet spot between making the app cutting edge, but also making how it works on older devices.
Right. It's a delicate balance, but it's super important to think about all those things from the very beginning.
I bet. And design plays a big role in all this too, right?
Huge. You got to create layouts that adapt to different screen sizes. Use fonts and colors that are readable on any display. And make sure all the touch targets are easy to hit no matter how big or small the screen is.
Wow, so it's not just about making the app work, it's about making it work well on every device.
Exactly. And we can't forget about performance either.
Right, because nobody wants to use a slow, laggy app.
Exactly. Users expect apps to be responsive, smooth, and fast, no matter what.
So how do developers make sure their app is performing well on all these different devices?
Well, for starters, they have to write really clean and efficient code.
Okay, so it starts with the code itself.
Yeah, but it goes beyond that too. They have to optimize how the app uses things like memory and processing power.
Right, those are limited resources on a phone.
Exactly. And then they also need to do a ton of testing.
On different devices?
Yep. And they use special profiling tools to find and fix any bottlenecks that are slowing the app down.
Interesting. So performance optimization is like a constant process. It's not just a one-time thing.
Definitely. It's something developers have to keep in mind throughout the entire development process.
That makes sense. On top of all this technical stuff, and we can't forget about the user experience. Like, an app could be technically perfect, but if it's not intuitive or easy to use, people just won't bother with it.
Absolutely. You're totally right. It's like a restaurant that has amazing food, but the service is terrible.
Haha, yeah.
People might try it once, but they're not going to come back for more.
Good analogy. So developers really have to think about things like navigation and layout and make sure the app is actually enjoyable to use.
Yep. It's all about putting the user first.
And all of this while keeping up with the latest Android updates and trends. It sounds pretty demanding.
Oh, it definitely is. But that's also what makes it so exciting. There's always something new to learn and new challenges to tackle.
Well, my mind is officially blown. This deep dive has really opened my eyes to all the work that goes into making those apps we use every day.
And honestly, we've just scratched the surface. There's so much more to explore in the world of Android development.
I can imagine. So for anyone listening who might be interested in getting into this field, what advice would you give them?
I would say jump right in. Start exploring the tons of resources available online. Experiment with building simple apps and connect with other developers. There's a huge community out there that's super supportive and helpful.
Yeah, the Android community is awesome. And remember, every great app started as just an idea. So if you have a vision for an app that could solve a problem or entertain people or connect people in a new way,
don't be afraid to go for it.
Exactly. The possibilities are endless. Well, that's about all the time we have for today's deep dive into Android app development.
It's been fun.
I learned a ton. I hope you did too. And be sure to join us next time for another fascinating topic. We'll see you then.